Okay, we're going to today look at tangent ratios, specifically trig ratios. And what I think I'll do is we will, tell you what, let's just kind of break off here and talk about, in general, trig ratios. This is a term that's going to come in handy to know. SOHCAHTOA. And what that is, it's just kind of a quick way to remember these things. But if I've got a triangle, a right triangle, and I've got, let's call this A, B, and C, and the side lengths are X, Y, and Z. The trig ratios of right triangles do not change no matter how large they are. If you have a certain angle measure, then the ratios of the sides are going to be the same no matter how small or large the triangles are. So if I have an angle, which we'll look at angle C, we'll look at the sine ratio first. The sine ratio is equal to the O opposite side over the H hypotenuse. So in this case, we're looking at the sine of angle C. Opposite would be Y over hypotenuse, which in this case is Z. So that's the sine ratio of this triangle. That's where we get sine opposite hypotenuse, SOH. So now SOHCAH is going to be cosine, and the cosine ratio is adjacent over hypotenuse. So now suppose we're looking for this cosine of angle C, that trig ratio. We're looking at adjacent, which is X, over hypotenuse, which is still Z. That would be my cosine ratio. And the last thing we would look at would be the tangent ratio. Now the tangent ratio is opposite over adjacent. So if we're talking about the tangent ratio of C, we're looking at opposite Y over adjacent X. That would be the tangent ratio. All these things, today we're specifically focusing on our tangent ratio. Tomorrow we'll continue to take a look at sine and cosine, but today we're going to kind of specifically look at tangent and how we can use it to find missing angles and missing sides of a triangle. So let's kind of go back to our notes. Now, if we're looking for the tangent of 72, that means we're looking for the tangent ratio of an angle in a triangle that is 72 degrees. Well, all we do in our calculator is we press the tangent button, which most of the time gives you that parentheses, put 72, hit enter, and you should get, and we'll round tangent ratios 4 places past the decimal point. So we get 3.0777. And that would be my answer. That's the tangent ratio of 72. Again, do it for 42 degrees. The tangent ratio of 42, hit enter, is 0.9004. That's the tangent ratio of 42. Now look at this next example. We don't know the angle, we know the tangent ratio but not the angle. This is when we use the tangent, the inverse, and I'll zoom in here so we have more space. And what we do with this is we first hit second, then we hit tangent, and when you do that, you get the tangent inverse, which allows us to find the angle that we're looking for. And what we do is we put in parentheses, we put the tangent ratio. We put 0.4876. And when we put that into the calculator, and we'll round this since we're talking about an angle measure, to the nearest degree, it would round to 26 degrees. So 26 degrees has the trig tangent ratio of 0.4876. So there's my answer. Do the same thing. Hit second tangent. You'll get that in your calculator. You'll put the tangent ratio of 0.9235 in, hit enter, and we're rounding, so we will round this to 43 degrees. Now if you're not getting any of these answers correct and you're using your calculator, hit the mode button. Make sure that degrees is highlighted and not radians. Okay, that seems to be the common mistake when dealing with that. So let's look at an example here. First type that we're going to look for, here we have an equation, and what this equation means is we've got a right triangle, we have a 42-degree angle. Again, tangent is going to be based on degrees. We're not going to ever put tangent and then a side length. It'll always be a tangent of a certain degree. So remember, the tangent ratio is opposite over hypotenuse. So x is the opposite side. I'm sorry, we're dealing with tangent. Opposite over adjacent. X is the opposite side over adjacent, which would mean 28 is the adjacent side. So basically we're using this trig function to find the missing side length of a right triangle. So we would solve this no different than we would solve a normal algebra problem. If we had this, we'd want to get that fraction. We'd want to get that x by itself. So we would multiply 28 times both sides. So what we would have is 28 times tangent 42 equals x. Now that, all we do now is just put it into our calculator. So 28 times tangent 42 equals, and we will round it to the nearest tenth place, and when you do that, you get x equals 25.2 is your answer. That means that this side of that right triangle has a side length of 25.2. And that's how we use these trig functions to, that's what we use them, how we use them, to find missing sides, among other things. Now the other type is we have this triangle. It's a right triangle, has an angle measure of 58, opposite 34 over adjacent x. The difference here, we're trying to find this bottom length as opposed to the opposite length. So we still want to get the x by itself, but notice the x is in the denominator, so we multiply times x to get rid of the fraction. That leaves us with x times tangent 58 equals 34. Well, I still want the x by itself, so I'm going to divide by tangent 58. I'm going to do that to both sides. And I end up with x equaling 34 divided by tangent 58. And all you have to do there is plug that into your calculator. And when you do that, 34 divided by tangent 58, round it to the nearest tenth place, x is going to equal 21.2. So that is the side length of that part of that triangle. Alright, let's look at the next type. To me, this is the easiest. This one right here that we just finished, example or type 2, seems to be the most difficult because it has that one extra step of multiplying by x and then dividing by tangent. To me, this is the easiest one because what we have here, again, we have a missing angle. If you're missing the angle, we're going to use that second tangent option, or second tangent. And what you do with that is you end up with this in your calculator. This is my tangent ratio, and you hit enter. And really, I should have mentioned this. This is a right triangle with an angle that we don't know what it is, but the ratio is opposite 5 over adjacent 8. We're looking for that missing angle. When I put this in my calculator, we get 32. Now we're talking about degrees, so we're just going to go ahead and round it and say that x equals 32 degrees. So we were able to not only find missing side lengths, but we can also find missing angle lengths. And we kind of did this part of our notes earlier. Tangent is opposite leg over adjacent leg. Using that picture, we would say that tangent of A is opposite y. There should be a y over adjacent x. Now on the on the other side of that, if we're looking for the tangent of angle C, the opposite is going to be x over adjacent y. Okay? And we would never look for the tangent of the 90-degree angle, only the other two angles that we're dealing with. Okay. 3 more examples before we take a look at the assignment. So here we have a triangle. My angle measure is 36, and I have the opposite, and this would be the adjacent, and this would be the hypotenuse. So if we can identify those 3, it makes it a little bit easier. So we're looking for the opposite, we have the adjacent, so we're going to use the tangent ratio. So tangent 36 degrees is equal to opposite, which is my variable, over my adjacent, which is 7. Now we want to get rid of that fraction, multiply by 7, and x equals 7 times tangent of 36. When we plug that into our calculator, round it to the 10th place, we get x equals 5.1. So those cancel out, and x equals 7 times tangent 36. Okay, let's look at example 2, a little bit different. Tangent of 49 degrees is equal to opposite 33 over adjacent x. So remember, when the x is in the denominator, we still multiply by that denominator. The only difference is now we have x tangent 49 equals 33. We still want to isolate that x, so we'll divide by tangent 49. So x equals 33 divided by tangent 49. And when we plug that into the calculator and round to the 10th place, x equals 28.7. Alright, and then one more example. Look at this one. We're missing the angle measure. This one should trigger off that second tangent option. As an equation, it looks like this. Tangent x equals opposite 19 over adjacent 22. We hit second tangent, so we get the inverse option. And we put 19 divided by 22 inside of there. When you hit enter, it will give you the angle measure. We'll round to the nearest angle. X equals 41 degrees. Okay? Let's take a look at the assignment. We'll kind of break down each section. All right, look at 1 through 4. 1 through 4 should not be a problem because all we're doing is plugging into our calculator tangent of 67 degrees, tangent of 3 degrees. Again, you'll be going to the nearest round it to the nearest 10,000th place, which is 4 places past the decimal. number 5 through 8, this is where you have the missing angle. So don't forget this section. You're going to do second tangent to get the inverse. And all you'll do there, it should look like this. Enter and you'll get your answer. Nearest degree, which is basically the nearest whole number. Now number 9 through 6 through 12, this one, all you're doing is you're not trying to solve for a value, you're just finding the trig ratio. Sorry about that. You're just solving the trig ratio. So the tangent of angle Z, what's the trig ratio? Opposite over adjacent. That's it. Nothing more than that. Just finding that opposite over adjacent. Okay, and then we have 13 through 22. They have those two types. 13 through 22 are going to be example 1 or example 2. I will look at number 13 because it is like example 2. I'll set it up for you and kind of remind you how you would solve that. So we have angle 25. Again, that's going to be the tangent. Tangent 25, angle measure is where we use that. Opposite, 17 over adjacent, x. Solve for x. Get rid of the fraction. Once we do that, we divide by tangent of 25. Okay, cancels that out, and x equals 17 divided by tangent 25. That will be your answer, which, rounded to the nearest tenth, you should get 36.5 if you want to check to see if you're doing it correctly. Okay, so that's one that was like example 2. Example 1, let's look at 15 to look at one that was like example 1. Here we're going to look at the tangent ratio of 51. That's equal to opposite over adjacent 19. So, get rid of the fraction, multiply by 19. When I do that, it isolates the x, and x is equal to 19 times tangent 51, which if we're still running to the nearest tenths place, you should get 23.5 if you want to check your work to see if you're doing it correctly. Okay, you're going to have either one of those two types on 13 through 22. Now 23 through 24, notice you do not have any angle measures. You have all the side measures, so that's where you're going to use that inverse. All of these problems, you're going to use the second tangent option. So if we're looking at 23, we don't know this angle measure, it's x, so the tangent of x is equal to opposite over adjacent. We hit second tangent, we get the tangent inverse, and we put 7 over 23. Hit enter, we're rounding it to the nearest degree, and when we do that, we find out that x is equal to 17 degrees. Alright, that's it. That should help you with this first assignment. Look into the trig ratios of tangents.